Hi everyone, today we will explain about polar and nonpolar in chemical bonding. What is polar? In chemistry, polarity describes the uneven charge distribution in a molecule, creating positive and negative regions. Here are the key points. Polar molecules. It has unequal electron sharing due to differing electronegativities. It has a net dipole moment, acting like tiny magnets. The examples are water, ammonia, ethanol. Nonpolar molecules. It has equal electron sharing or symmetrical cancellation of polar bonds. It has no net dipole moment, no positive or negative regions. The examples are oxygen, methane, carbon dioxide. Now we will show you some experiments that hopefully will help you understand better about polar bonds. The materials needed in order to the experiment is quite simple actually. There are only 5 of them, which are cooking oil, such as vegetable oil, rubbing alcohol, 2 small cups or containers, food coloring, and stirring rods or spoons. Now, we will explain the procedures of the experiment. First, pour a small amount of cooking oil into one of the cups. Then, pour a small amount of rubbing alcohol into the other cup. After that, add a drop of food coloring to each cup to make it easier to see the substances mixing. Use a stirring rod or spoon to mix each substance gently. As you can see, the cooking oil and rubbing alcohol will behave differently when mixed with the food coloring. Food coloring readily dissolves in rubbing alcohol. This is because the vibrant hues of the food coloring disappear into the clear alcohol, forming a homogeneous solution which indicates a strong interaction between the two substances. Meanwhile, in cooking oil, food coloring remains separate. Despite stirring, the food coloring forms distinct droplets within the oil, refusing to mingle. This suggests a lack of attraction between the molecules. Next, we will analyze about the connection between cooking oil and rubbing alcohol with polarity. The first is about the molecular architecture. Food coloring molecules possess polar covalent bonds, meaning electron sharing is unequal, creating slightly positive and negative regions within the molecule. Rubbing alcohol also exhibits polarity due to its hydroxyl group, attracting both positive and negative charges. In contrast, cooking oil molecules consist mainly of nonpolar carbon-hydrogen bonds, resulting in a symmetrical charge distribution with no distinct positive or negative ends. The next one is about the intermolecular forces. Polar molecules experience dipole-to-dipole attractions, where the positive end of one molecule is drawn to the negative end of another. This electrostatic attraction drives the dissolving of food coloring in rubbing alcohol, forming a uniform solution. Conversely, nonpolar molecules lack these attractions and instead rely on weaker London dispersion forces, which temporarily induced attractions. These forces are insufficient to overcome the separation between the polar food coloring and the nonpolar oil, leading to immiscibility. In conclusion, this experiment effectively demonstrates the role of polarity in shaping intermolecular interactions. By observing the stark contrast between the behavior of food coloring in polar and nonpolar environments, we gain a deeper understanding of the forces that govern the world around us, from the mixing of ingredients in our kitchens to the intricate workings of biological systems. That's all. Thank you for your attention.